This is a video recording of the possible solutions for lesson 2.1 and 2.4. So I wanted to give you a fallback so you can go back and look at things that you had missed or things that you might want to correct in your thinking before we take our test, or if you're planning on retake. So in question number 1, it says, in the sport of cliff diving, competitors perform 3 dives from a height of 28 meters. The table shows the speed of the diver at various distances in the dive. Sketch a scatter plot on the data of the given coordinate plane. So most of you did very well on that. I'm not going to take the time to do that. I'm going to show you the scatter plot that I have in the computer or the calculator. But letter B said, use your regression feature in your calculator to determine a power function to model the data. So I thought I was being kind by telling you to use a power model rather than having you go through and try to find a quartic, quadratic, cubic, and see which one made the best fit. The best fit for this one is a power model. And what I did is I took the time to put all these values into the stat editor already. So just to show you, I put in the stat, I edited the list, and I got the distances in list 1, I got the speeds in list 2, and then I'm going to look at my scatter plot. So to create that scatter plot, I've set the window to mirror the window that I have on my graph already. So I went from a -4 to 32, I did tick marks of 4, then I went from a -4 to 24 on the y's, I went by tick marks of 4. Then I went and I set up my stat plot. So I went to stat plot and I turned this plot on, and I wanted to make sure that it was going to a scatter plot, and my x's were list 1 and the y's were list 2, and I'm going to use that for a mark. And then I went and I graphed it. So that's the scatter plot, which many of you were very successful in getting on your paper. So what I'm going to do now is I'm going to run the part in part B. We're going to use a regression feature on a calculator. So I'm going to go under stat and we're going to calculate. And I specifically asked you to run a power regression, and many of you were doing the quartic and cubic and quadratic that we had done in some exercises. This came out of the other lesson that was on power models. So there is a power regression feature on your calculator, so I'm going to run that power regression. The x's are in list 1, the y's are in list 2. I'm not using a frequency list, but I would like to store this regression equation in my calculator, so I'm going to hit the vars. I'm going to store it in the y variables, and it's a function, and I'm going to store it in y1. And I'm going to calculate, and it's going to tell me what my power regression should look like. So first of all, it's telling me that my power regression, and I'm going to take a picture of that and have it on my screen here, should fit into this model where we have y equals a times x to the b. Okay, so there's my power model that I'm going to write in here. So I want to make sure that I write out this equation the same way they have it. So I want y equals the a value, and we're going to round to the nearest hundredth or so. So 4.42 times, now it's going to be times x raised to the value of b, and b is 0.50. In essence, when you raise it to the 0.50, it's basically a 4.42 times the square root of x. If you remember, this is x to the 1/2 power, basically. So we're looking at a square root model, which should be a Nike sign, and if you remember what that graph looked like, it does have the appearance of a Nike swoosh that we talked about in class. So if we look at that graph again, that scatter plot looks like the Nike swoosh, and here comes my best fit curve. So that's my power regression on the best fit curve. Now I want to take that equation and I want to figure out if we use the function to predict the speed at which the diver will enter the water from a cliff at 30 meters. So if I have a distance of 30 meters, what would their speed be? So what I'm going to do is basically calculate our y equals 4.42, this is our prediction equation, times x, and x in this case we're going to do this at a distance of 30 to the 0.5, or the square root. So we run our calculation and we should end up with our desired answer, their speed at 30 meters. So slide it over so I can read. We'll go back to the home screen and we'll run the calculation. We'll multiply 4.42, we're going to take it, times x raised to, which is 30, I'm sorry, I should have put in my times sign, 30 raised to the 0.5 power. Enter, and it's 24.209. Now you could get a little bit better approximation if you wanted to use the full equation that you had in y1, or y equals, and I could go ahead and I could calculate a value. So I'm going to do a table set, and I'm going to start that table at 30. Hopefully I can get a 30 in there. So at 30 meters, and enter, and I'm going to look at my table value and see how close I really am. So 24.254 is a little bit more accurate because I'm using more digit precision, but that's not the whole nature of this problem. The nature was making sure that you can plug this back into your equation and come back with an answer that's relatively close to 24.25. So curve fitting with your graphing calculator and the regressions for a power model.